Chain rule, chain rule. Time to face the change, chain rule. You know, we did this in class yesterday, chain rule, and I thought I would post the notes and some homework. And then while I'm looking at that, I'm like, there's so many little things, to not forget. I thought I'd make a quick little video, okay? Because how I'm really good at that. Chain rule. First of all, if the function, okay, is written as f of g of x, right? And you want to take the derivative. So the derivative of a composite function, the derivative of something that would require the chain rule. So this is the actual formal definition of it. And I never write this at first because I think when you write this first, it's more complicated. But maybe this makes more sense now that we practiced a few of these yesterday. With the chain rule, remember, you start on the outside and you work your way inside. So the first thing you do is you take the derivative of f. The f function is the one that's on the outside, right? You take f prime. I'm missing a parentheses there. Oops. Oh, son of... Of course it did. Yes. Wouldn't want it to work for just 5 minutes of a video, that would be too much to ask. We gotta log back in. Unable to connect. Forgotten how frustrated I was with this whole process because I haven't had to worry about doing this with the Google Meets. F prime of what? Of g of x. Okay, the derivative of the chain rule function is the derivative of the outer function still evaluated at g of x. Then you got to multiply by the derivative of what's on the inside, g prime of x. Okay, so it is kind of important to maybe see that written out formally. Chain rule. Boom. Maybe you missed class, so this video will help you guys. And all the examples here, I'm going to post these notes as a PDF, but these are the same examples we did in class. So if you have the quantity 2x plus 1 squared, right? What the chain rule just said was you take the derivative of the outer function. The derivative of x squared is 2x. Notice behind the x, though, is actually a 2x plus 1. So that's why I kept it in green, 2 times 2x plus 1. Then you multiply by the inside function's derivative. The derivative of 2x plus 1 is 2. Okay. Example 1, we foiled it, and we used chain rule. Okay. So scrolling through all these other ones, there might have been a few variations between 6th period and 7th period, but for the most part, they're all here. You can look at them, but there's one other thing I meant to mention. Well, a couple things. First of all, 6th period, what up? 6th period, we ended right here because it was like 1:25, and you guys were like, Mr. Quirk, we have class at 1:30. I was like, oh yeah, that's right. Whereas my 7th period, we had class at 9:30, and at 10:30 we didn't have class, so I just kept going longer. So in 6th period, I stopped with this answer right here. 4 times the sine of 2x minus 1 cosine 2x minus 1. Right? We used the chain rule. We rewrote the sine squared as something squared. And what is the something? It's sine of something. And what am I taking the sine of? I'm taking the sine of 2x minus 1. Right? So it's like 3-layer chain rule. Ogres are like chain rule. So what's the derivative of something squared? That's 2 something. What's the derivative of sine something? That's cosine something. And what's the derivative of 2 something minus 1? That's just 2. Okay. So what I did do in 7th period, because there was a little extra time that I stole from your lives that did not happen in 6th period, okay, was brought up a good friend from our past, the double angle formula for sine of 2 theta. The double angle formula from pre-cal is 2 sine theta cosine theta. This is just an identity. This is a true statement. You can read it from left to right or right to left. It works. What you can also do with this thing is divide the 2 to the other side, right? So you get sine theta cosine theta. So as a math teacher, whenever I see a sine theta cosine theta next to each other, okay, like in this derivative up here, I think of the double angle formula for sine, okay? There's also a double angle formula for cosine that gets used in calculus. Later on down the line, I'll bring that up. But the double angle for sine, okay, uh, written in this second form here is 1/2 the sine of 2 theta is sine theta cosine theta. And again, I can change these thetas to be a different thing as long as they are the same thing, right? Notice this is sine theta cosine theta. It's not sine of x cosine of y, right? That would be bad. That would be different. Then you would not use this formula. But when they are the same thing, like 2x minus 1 and 2x minus 1, I can rewrite the sine of 2x minus 1 and the cosine of 2x minus 1 is 1/2 the sine of 2 times 2x minus 1, right? Which is what the other side of this formula over here says, right? 1/2 sine 2 theta. And then I can distribute the 2 and 1/2 of 4, because there's a 4 in the front for my derivative. This is a slightly neater and cleaner answer, right? 2 sine 4x minus 2 is less writing than this other answer that we have up here. Now, would that be mandatory? On a free response question on the AP exam, you do not have to do that at all, okay? That's going way above and beyond. Don't do that. Is it possible that on a multiple choice question they do something terrible like this? And that is maybe kind of possible. It is possible that identities get used when you have an answer with trigonometry and you want to like redo it. Okay, so that could happen. Could happen. Not necessarily, but it could happen. So that's why I just did it here, just because it's like it's good to see how these things can work out. As I'm going through to pick homework problems, I'm going to continue with example 9, new page, and of course, close that out. Yes, I'm aware you're unable to connect. It didn't like it when I created a new page. It was like, yo, bro, what are you doing? No, don't push that button. Sorry. I have to do it on my tablet. I'm going to type in my password, which is I hate you, stupid Mirror 360 device. Actually, I don't think it's the Mirror 360. I think it's my laptop. My laptop is having problems. Please work. Okay. It might work. What if your function is, and I forget what example we're on now because I've lost track. 10, maybe 9. Sorry. 1 over x plus 2. Okay. When you look at this fraction, I would understand you would think chain rule. I mean, you would probably think quotient rule, right? Quotient rule, you have the derivative of the top, which is 0 times the bottom, minus the derivative of the bottom is 1 times the top, which is 1, all over v squared. And that would be cool, right? That works. And the 0 times x plus 2 goes away, and you have a negative 1 times 1, which is negative 1 over x plus 2 squared. Okay, but another use of chain rule, because we had that derivative at the top was 0 problem, same guy here. I could rewrite 1 over x plus 2 as the quantity x plus 2 to the negative 1 power. Okay, this is kind of the more like generally accepted method, is to use chain rule instead of quotient rule. So now it's like a function, right, on the inside with a different function to a negative 1 power on the outside. So y prime would be negative 1 times x plus 2 to the negative second times the derivative of what's on the inside, which would be 1. And then you can rewrite the negative 2 power, right, back in the denominator as a positive 2 power. So it's the same answer either way, okay? It's not necessarily any shorter to do chain rule, but it's kind of the more like I said, generally accepted way to do it when there's a constant on top, okay, when there's a number on top. So as I was looking through some of these homework problems, um, I, I saw some that were like especially gross unless you think to rewrite that fraction first. Okay, like one like this one, uh, y equals, say it's 1 over x plus 5 to the third power. So again, there's a quotient. That is a clue that you might want to use quotient rule. But the thing with the quotient rule is the quotient rule is inside a chain rule because it's a quantity cubed and then a quantity on the inside, right? So you would take the derivative of the outer function and then the derivative of the inside part would require quotient rule. Well, instead, if you just think about moving the x plus 5 up to the numerator like I did in the previous example, right? And it's still raised to the third power. What you end up with is x plus 5 to the negative third power. And now it's a much simpler chain rule problem. So negative 3 times x plus 5 to the negative 4 times the derivative of what's on the inside is 1, right? So it's just negative 3 over x plus 5 to the fourth. Okay, so rewriting a quantity in your denominator up into the numerator with a negative power. It's just a trick that I didn't have time to go over in class, and I thought maybe I should talk about this now. So I hope you guys watch this video, even on double time, right? It might not be as long. And so, same thing if, Mr. Quirk never stops. What if you had a square root in your denominator, right? So it's like 5 over, let's do something different new, the cube root of 7x plus 9, okay? So you can rewrite the cube root as a 1/3 power, right? Cube root is a 1/3 power. You can also move the radical out of the denominator by making it a negative power. So this is much easier to think of as just a straightforward chain rule problem rather than a quotient rule problem that involves a chain rule problem, okay? Now, my suggestion to you is if there's an x on top, use the quotient rule, okay? Some teachers would actually say you can use product rule now instead. I personally, I feel like when there's a variable on top, you should just stick to the quotient rule. We can look at an example of that another time. This video has already been too long. So the derivative of this is negative 5/3, 7x plus 9 to the negative 1/3 minus 1 is 4/3. And then what else do you have to remember to do now? This is where mistakes happen because you got so much going on. Remember, it's the derivative of the outer function times the derivative of what's on the inside. That's 7x plus 9 wants to get a derivative too. You know what I'm saying? Who wants to get some derivatives? Everybody wants to get some derivatives. And of course, just when I was about to write the final answer, it doesn't. Just when I thought I was out, they bring me back in. So you guys write the final answer. Write what you think the answer should be. I'm going to do that too, and then you can check, yourself once once I log this stupid thing back in. But I'm going to go ahead and just write it first. Hopefully, when it comes back. Gosh, there's so many different ways you could write it because of the dumb radical. I'm not even going to use a radical. Forget it. Come on, let's go. Okay, so you can multiply 7 times negative 5 and get negative 35 over 3, blah, 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 to the negative 4/3 power. You could then move the negative power to the denominator and make it a positive power. Positive 4/3. You could then rewrite it as the cube root of 7x plus 9 to the fourth power. Ugh. Oh well. Have a good weekend. Chain rule.